Okay, here we go for the third and final class of the day. We just graded what little we had for homework 6. That was about binary trees. And now we're gonna go over chapter 7 of the classical Kernighan-Ritchie textbook. Chapter 7 starts with stuff that we already know because we've actually been using standard input and output since chapter 1 when we do things like get char to read, usually from the keyboard. And I've also shown you guys with the very first exercises already, how you could redirect from a file and how we could also redirect to a file the output. So we're dealing today with the same library, this STD, the standard IO input output that we've been using before. So all this get char, put char stuff, it's also standard output. When we do use a printf, we're doing a formatted output because we're telling it that we want this to be formatted with a certain like width, for example, how many decimals we want, how many places do I want the integer field to occupy. And these are all the things that we've been visiting before. There are some really good examples here in the book about how you can control things like the length of fields, and all of this stuff is in our reference card. The stuff that we're going to be really interested in today has to do with the file access, because we already know how to do printf. We already visited scanf a tiny bit. So now we want to do those things using files. That's the important take-home lesson here. And once you're familiar with files, you could also start experimenting with what's standard error, meaning that instead of just printing normal printout, we can send two different streams of printout towards the operating system. One that's kind of like the intended output, and one that's exclusively for errors, so that we could redirect the standard one to a file and then errors to another file, or we could look at the errors and leave the standard output going towards a file. So we're really interested in section 7.5, and I took a little screenshot for you guys of the notation we need from the reference card related to that. So when we want to access a file, we're actually going to declare a pointer to a file access thingy. Then we are going to open a specific file in a specific access mode. It could be reading, writing, or appending. The difference between writing and appending is that if I write, the previous content of the file disappears, and whatever I write there will substitute whatever was there. Whereas appending means that whatever is now in the file stays in the file, and after that content, I will be adding new content. I can also, when I have a pointer to a file, if it's for reading, I could take characters from there. It's like the get char, but it now comes from the file. Or I could send a character there with the put char, but now sending it to the file. The same way I'm going to be able to use the printf, that the scanf, but to a file or from a file. When I don't want to use the file anymore, I'm going to use the fclose to close the pointer. And I can check whether the file has ended by calling the file end of file, which is the feof, to check what's in there. So we're going to make a little bit of testing on how those things work today. And then you're going to have a homework assignment that has to do exactly with those aspects. I've already also taken screenshots for you of the 2 mini exercises. We only have 2 this time. The first one has 2 different blanks in it. So we have a little blank inside a while and a little blank inside an if. And what you're going to be adding to those blanks is essentially you want to make the program that while the file hasn't ended, pull the characters one by one and check if they are new lines, because we're going to make a line counting program. So you're going to finish my code so that it actually counts the lines given in a file. And the second code, we're going to be reading a file that for each line contains student info, like student ID, study program, grade. And we're going to read that file line by line, and we're going to print in the standard output what did they get. So what you're going to be putting in the blank, it's going to be an scanf that reads a specifically formatted file. You're going to read a 7 position string, a 3 position string, and then an integer number. And we're just going to pretend we're going to use the 3 position student program now abbreviations. Some of the programs like mechatronics, you sometimes use a 4-letter one for them, but actually inside the student information system, those are all 3-letter ones. So they're shorter there. So just pretend they're all 3 letters when you write your fscanf, and you should be fine with the mini exercises. So those should be easy to do when we're done checking the contents of specifically section 7.5. But let's just kind of scan ahead here because I think you guys might not have read this. So there's a discussion on how does it work that printf and scanf can take a variable number of arguments depending on how many fields we're writing or reading. So if you have any doubts about how scanf actually works, you really should read this because this is very helpful. And what we're going to start doing now is this part. We're going to open accesses to files. We're going to read things from files, and we're going to write things to files. So let's try that. I'm going to make a little terminal here for that exact purpose. We're going to go to the repository. We're going to go to chapter 7. So I have some files here. Let's take a look at my files. I have this one. This is very much like the one we were talking about for the second little homework assignment. I have some numbers. I have some study program information. I have some names. So we could first try to make a program that reads this file. Let's make another terminal and try to read this file. So we'll call this demo agosto-diciembre 21. And let's this be the first demo that we're making this semester. So I want to read this file, and I just want to put to the standard output what's in the file. So I'm going to need the standard library for accessing files. No way around that. And I'm going to need a little main routine. It's going to need to return some kind of an integer. And as said, we're going to need a pointer to a file. So the source that we're going to be reading from, it's going to be a file. I wish to open file, and the file I wish to open is the datos.txt, and I wish to open it for reading. Then I could do something here to the file, and when I don't want the file anymore, I will close the file. So to make sure that we're doing this right, we want to compile before we try to do anything more complicated. And since it compiles, it means everything is in order. I can try to also run it, because if the file doesn't exist, we're probably going to get a problem. In this folder, the chapter 7 folder, there is a file, datos.txt. But let's say I temporarily rename it to something else. And I run my program again. It's still acting like everything's fine, but the file doesn't actually exist. So while I don't try to read the file, I seem to be safe from having a problem, even when datos text doesn't exist. But let's revisit this thing once we're actually reading the file. So let's make something else, again, be datos.txt, and now try to actually read it. Let's first simply read it letter by letter. So while the file hasn't ended, I want to read it letter by letter and spit the letters out into the standard output. So let's take a character variable here so that I can now do the get char, but I'm doing it from my source file. And then I could print, I can just use printf so that it's a little clearer what's going on here. Let's just write them on a separate line each, all of the letters that I am getting from this file. Compiling, executing. So now I am getting one by one the letters from that file. And if I now wanted to do something like what I'm doing in that homework thingy, if I wanted to count the lines, I could make a line counter here. Then instead of printing, I could be comparing if the character that I read was a new line. I'm writing Python again, sorry. Actually, I'm fine, it's character. If it's a new line, then I want to increment my counter. If it wasn't a new line, then I could just ignore it. And at the very end, I could print how many lines I had. So I'm compiling, I'm executing, and it's telling me there are 6 lines in the file. 1, 2, 3, 4, 5. Okay, this program would be a little bit more useful if I didn't hard code here what's the name of the file. Last time we learned that we can actually get command line arguments. So I could take the first one of those. Remember, I don't want the 0 one because it's the name of the executable. I could take the first one of those and open that file instead. So if I run this using datos.txt, it's going to have 6 lines in the file. But I could actually even send the same source code in there. And now it read a different file. It read this one, and this one had 16 lines. Notice it didn't actually count this line because it doesn't have a new line there. So it should still have 16 if I do it like this. Yes, I have 16 lines there. And now I can actually ask the program that I have in the operating system, how many lines do my files have? So now it, for example, entrada.c, that has 30 lines. So let's see if my program agrees. There are 30 lines in the file. So this is essentially the gist of it this week. Okay, so now this is our first demonstration. Let's make a copy of that demonstration and modify it so that it's also going to write a new file. So now I have a source file. Let's also make a target file. And I want to write to this target file. And I could use a second command line argument to specify where I want to write. Now remember, writing is going to replace that file, so never write in files that are important to you. So now let's stop counting. No, I erased the wrong line. I am still going to want to close source. I'm also want to close target. What I want to change the program to do now is while it reads character by character, it spits the same characters, but all in uppercase into the new file. So this is kind of like a parent simulator. It just puts everything in uppercase. So now we need to remember how to make stuff to go uppercase. We need the ctype.h to use the to upper. So let's include that. I can't type. And now when I read the character, I am going to want to send it. We can check here, how do I send? Write a character with put C. First, I need to say what's the character and then where I want to send it. I want to send it to target, but what do I want to do to it? I want to first, let's put it actually here. Once I've read it, I want to make it uppercase, and then I want to send it to the other file. Okay, so let's try to compile this one. And now if I take this, let's say I will send it datos.txt, and let's send it all to mom.txt. It's actually my mother's birthday today. Then we can look at what is in that file now. That file now contains uppercase versions of everything, including the end of file character. So we might not want to do it with the end of file character. We could just make it so that we only do it with alphanumerical characters, because that kind of makes sense, that you don't try to make stuff uppercase if it isn't actually even a letter. So let's add an if here. Let's just first read the character. Then, if it's an alphanumerical character, only then I'm going to make it to uppercase and send it to the file. I'm going to ignore all other characters. So now if I compile and I run it again, now my file only has the alphanumerical characters. Notice it doesn't have the space anymore, and it doesn't have the new lines anymore either, because those are spaces. So I could also put it here that I only make it uppercase if it's an alphanumerical one. And after I've done that, I send it to the file. Okay, so now all the alphanumerical thing is, all the letters are uppercase now, but all the other symbols remain unchanged. So now I'm also writing to a file. The remaining thing we want to check is, in addition to checking if there's stuff in the file, opening files, closing files using the getC and the putC, it would be cool to briefly visit how do the fprintf and the fscanf work. They work pretty much exactly as you would expect. Let's see if we already have a good demo of them. Yes, we do. Let's look at these that we already have in the repository. Okay, so this is pretty complete as an example. What we have here is actually also a header file, entrada.h. Let's go see what it has. It defines a structure where we put a study program username and an unsigned number, and those are students. So I guess this is going to be the student number. There's going to be a username and there's going to be a study program. We have 3-letter acronyms for the study programs. Usernames are going to be 8 characters long. We have a main. It's going to be reading that data file that we've been looking at. It's going to count how many users there are going to be. Then it's going to reserve space for the students. It's going to make an array of students. Then I'm going to using the rewind. I already have a file open. I already read the whole file. With rewind, I'm going to the beginning of that same file. so that I can read in the student data. Since I know how many students there are going to be, I can just like iterate over them now to make space for the first student, read, well, make the space for its study program abbreviation and for the username. And when I have the space, I am saying I want to read the unsigned integer, then I want to read two strings. The unsigned integer is going to go in the number in the structure here, and the strings are going to go in program and in username. So I need to give the address here because that's just a number. So I need a pointer to the number, whereas the other two are already pointers, so I don't need to take the addresses. When I've read all the data in, I am closing the data file. Then I'm revisiting the array of the student information. I'm printing out the student information in a different order now. I am printing the username. Then I am printing the, first I'm printing like a counter that is going to be student one, student two, student three, then their usernames, then their student IDs, and then the study program they're from. And I'm also liberating the array at the same time. So this example does a lot of stuff. Let's compile it and run it. So now I have students 1, 2, 3, 4, 5, 6. And then there is a student 6 that has some anomaly. Let's go look at the data. Okay, the reason why it has an anomaly is that we try to read here a number, but this isn't a number. So it's going to read it wrong because it's actually not a number. So fscanf is very vulnerable to when your data isn't in the format you said it would be. You get strange errors. If I change it into an actual number, everything works fine. So the lesson here is never ever use fscanf unless you are certain that your data will be exactly in the format that you are expecting. So if the data comes from another program, you are safe. If a person writes the data, you are unsafe, and it's usually a bad idea to use fscanf. It would be safer to write your own routine that uses the getchar equivalent to read characters one by one to build a string, because you can add any validations there. You can complain to the user if there's a missing character, if there's an extra character, if a character is in the wrong format, so that you don't end up with strange situations like here. When I have something that isn't a number, I also lose the other two fields. Okay, let's add the new stuff to the repository. And I had a second example here already existing that was using that. It was the salida.se. So let's look at salida.se as well. Okay, so what we are doing here is we're reading again the same file datos, and we're going to write into a different file that's going to be called reorden.txt. So we're going to be with fscanf reading the data. Then we are going to write it into the output file in the formats that we were just printing it to the console. And I'm using here the defines to make two different versions of this. One of them is supposing that there's actually a number in the number field. It's when convert is defined. When convert isn't defined, it's not going to do the conversion. So now, since my file has some stuff in it that isn't a number. We should remember that in datos, I left the LOL there. So now the version that's going to be more robust, that's not going to break, is going to be the one that doesn't convert. Let's try the one that does convert first, though, just to see what's going on. So if I run this one, it wrote something to the output file. We can look at what it wrote. It wrote this stuff. And remember, this part breaks because I was trying to use the number, lol as a number. So it got converted into a 0. If I disable the conversion part and I compile and run again, then it doesn't get converted into a number, so it gets copied as such. So this is simply a demonstration of if you really don't need it ever to be a number, and there's a chance that your user might write something there that isn't a number, just let it be a string. If you need it to be a number because you're actually going to do math with it, it's fine. You can convert it into a number. But doing conversions when you don't actually need to do conversions makes life much harder for your users and also yourself if you're trusting them to write numbers in places where they actually forget to write numbers. So that's essentially the important part. Please read very carefully section 7.5. It explains the part about opening the pointers. It revisits the part that I mentioned, that appending will add to the end of the file, while writing will replace the entire file. There are some examples here as well. A little program that concatenates files, like it takes several files and it puts them together. Then there's the explanation on the how to print to standard error. It's just like printing to a file, but you need to print to a special file that's called stdr. You don't really need to open it. It becomes accessible when you load the stdio, because that's where standard error is defined. Probably mentioned here somewhere, std in, std out, and stdr, just like the end of file character. Then technically, we could read things line by line. There's an fget_s, so you could just read the entire line and then start parsing it. You can try that easily. It's explained in the section 7.7. And then there are some pretty interesting things you can do with strings, with alphanumerical things. And there's also a little funny thingy called unget, which means that when you read a character, if you don't want it, you can put it back. Like if you wanted to read until a new line and then you read a character and like, oh shit, it's a new line, you can just put it back. Nothing bad has happened. You can process whatever you have, and the new line is going to be waiting in the standard output input or the file. So basically what remains to be discussed today is what's the homework for chapter 7. Let's go look at the homework for chapter 7. Anybody who's made it this far, this should be kind of like easy by now, because all of these things depend on previous things. If you've understood previous things, all of this stuff should be pretty easy. If you haven't understood the previous things, the absolute best advice I can give is to carefully read the preceding chapters of the book. If you're having trouble reading it in English, you can read the Spanish translation. It's fine. No one will judge you. And if there's any part of the textbook that you're having trouble with, just please post screenshots of the complicated part, and I will be happy to discuss that with you. Now, clever ones already noticed if you just write what I wrote here, you're going to get a point for the last mini exercise. But what we are about to discuss is the what do you need to actually program for next week. So what we're going to be doing for next week is we're going to fake a little database. By database, I mean instead of storing things in memory that's only available while the program is running, we are going to write stuff to files so that when you run the program several times, every time we're going to be reading that same file and writing into that same file so that we can have persistency, so that we can have things that keep existing between executions of that program. So I'm going to spend a tiny little while on the whiteboard trying to explain what this program is supposed to do and how we are going to check if it's actually going to be working. Okay, so we're going to have one or more files. What are we going to be writing in those files? We're going to be doing an access control of employees. So every employee you have is going to have a PIN code. So we could have a file that would kind of be like an employee list, employees txt. Elisa could be 1, 2, 3, 4. Then I could have some other person. We could have a John. John could be 4, 6, 2, 8. Then I could have a Matt who could be 1, 3, 5, 7. And I could have Joan who could be 3, 5, 9, 6, etc. So this is our list of what are the codes of the employees. So now when I go to work, let's suppose this is work. There's a little pin pad over here. So when I go to work, I type my pin in this thing. So basically we're going to need a program that could kind of like be the pin code typing program. And when I type 1, 2, 3, 4, what the program's going to do, it's going to write in another file, which is kind of like the assistant's log. It's going to write that I went at that time. It could just write 1, 2, 3, 4, entered at, like I said, let's say 8:15. And then let's say Matt shows up 5 minutes later, 1, 3, 5, 7 showed up at 8:20. And that's how it's going to be recording things. Then when I leave work later on, I'm going to type my PIN code again, 1, 2, 3, 4, and it's going to put here that I left at 5:35, for example. So I would be having this record of when did people enter and when did people exit. So now when they want to know if I was there on a given date, or how often did I go, or how many hours did I work, I would be needing to read this file, combining it with this file to know how many hours every person worked. First, worry about this part, at least putting the times. Of course, if we want to make a fully functional system, we would need to add here also the dates. Like, for example, today we had these, and then another day I could come back the next morning at 8:10 to work again. So I could make this really long log file of what time am I arriving and what time am I leaving on specific dates. Let me get you guys a couple of pictures. You're going to design your own system. It doesn't have to be like mine. I'm just going to give you the pictures of what I'm explaining here so that you can do something similar. So we're definitely going to need a program that writes things into the log file. And it's important you remember to use the append mode because you don't want to rewrite the whole file. You just want to add one line corresponding to what was the pin, what was the time, and what was the date. Then we're going to want another program that assigns the PIN codes to new employees. So that program, I don't know, new pin.c, that one is also going to be in append mode because it's going to add the new people here. So we could have a Jose, and Jose gets assigned a new pin code. You could just put them like in order, like the first person could be 0000 and then 0001, and they're kind of like employee numbers. So you design your logic on how to give numbers to new people. That program's going to do that. And then the difficult part, I'm going to be impressed if you guys pull this off, is kind of going to be like the human resources part. What the human resources part needs to do, it needs to take the list of employees from here. So it kind of needs a structure of what are the employees that exist. So it needs to know that there is an Elisa. It needs to know the PIN code of Elisa. And then when it knows this, it's going to have to read through all the log files. So it's going to open it in read mode. And it's going to run through here. Whenever Elisa enters, you need to look for when did she leave. And when you figure out when she left, you could do math to calculate how many hours did she work. So then we could have here different counters here. We could have, for example, days worked, that whenever she shows up, you increment the days. And you could have like an hours counter that whenever she did come, you calculate the difference. How long did she stay? And you add it to the hours worked. And when you do this for all of the employees, you could at the end of this program print out a list. How many hours has each employee worked so that you know how much you need to pay them? Okay? So basically, you could also make a little list somewhere that would say what time are the people supposed to show up so that you could check if they were late or if they left early. There are many, many, many things you can add. But first, worry about, I would first worry about this part. PIN code, time, date. PIN code, time, date, appending to the end of the file. When this is working, worry about this part. New username, what's their code going to be? New username, what's their code going to be? Appending to the end of it. When those are both working, you already have 2 or 3 points. Then start worrying about this part and go little by little. First, just check how many check-ins did people have. Don't even try to see if they're entering or exiting. Just count how many times does Elisa show in log.txt. When you have that, you can start worrying about when is she entering and when is she exiting. When you have that, you can start worrying about how long did she stay. If you have that already, you can start worrying about what time was she supposed to show up, what time was she supposed to leave, etc. So just try to do it gradually, little by little, own goals, own rhythm. Let me know if you run into any trouble. Just put your stuff on the channel. I will be happy to look at it. It's fine if you don't do all of this. You don't have to do all of this to get a semi-decent amount of points. Just do some of it. Okay. So I'll be very happy and proud of you if you're managing this part. It doesn't have to be the whole part. Let me get you a third photo of all that mess that's on the whiteboard now. And remember, it doesn't have to be exactly like mine. Just please, please, please don't copy some pre-existing system from a website and then pretend it's yours. It's really insulting when you do that. But other than that, it's fine if you cite some sources, if you have to base yourself on somebody else's code. Just mention it in the comments within your code. You can put there the URL, what's the thing that you were looking at to make this particular design. So let's make a little poll here. If you think you will be able to pull through some of what I just said is going to be in homework 7, just vote the green thing. If you have a question that you really need me to answer right now, we'll go for the question mark. If you need a little bit of time, but you think you might be able to pull through, then the confused face. The important part is reading and understanding section 7.5 and the examples in my repository. I'll link it to you guys one more time. You should already know where it is. So in the C part, this stuff is in the chapter 7. So there's a few programs, 1, 2, 3, 4, 5, 6 different example programs and a bunch of files that those programs read or write that you can base your work on. I will be here for any questions, difficulties, if you want to talk about your homework 6 some more, if you need guidance on the homework 7. And then next week, after we grade homework 7, we're going to talk about the project. We're not going to have a specific assignment about the chapter 8. Chapter 8 is very helpful, and there are many things there that could be useful as ideas for your project, but there's not like regular homework for chapter 8. Please take a look at chapter 8 anyway. There's important stuff there. And the book has a couple of really good appendices as well. It's a good idea to browse through those, even if you don't actually read them. I'll catch you guys next week, and I'll be staring at Discord until 5 in case you need any kind of help whatsoever. And also, if you had internet difficulties today, we'll be happy to look at your homework again next week. So we can look at the homework 6 and the homework 7. If there's something you wanted to show about the homework 6 but couldn't today because you didn't have electricity or internet at your home. So don't worry about it. We're flexible like that. And then also you can start practicing online in the online system. The final exam, it's a similar thing than I'm actually going to show it to you guys. It's a very similar thing that we had for the midterms. It just contains all this new stuff that we've seen in the second part. Like there's a lot of pointer related stuff, structure related stuff, type defs, file pointers, etc. But it's a very similar thing than you're already used to. So you can also practice this just the same. And if there's any confusion there, if it marks anything wrong that you think is right, just let me know. So it's a very similar thing. You can just see that there's a lot of pointer related stuff. There's going to be some function pointer related stuff. There's a structure right here. We're closing a file here, reserving memory, opening another file, closing a file again. So basically, I have no idea what this is. Oh, there's a routine declared here. Factorial routine declared all the way down there. Here it said that we're going to have it, and this is where it's actually implemented. So just practice with this thing and let me know if you have any trouble with it, and we should be fine. I'm not going to bother you guys with answering the mini exercises today because I know Jair doesn't have a good internet connection. So just if you run into trouble with those, first remember I already told you what you need to do. In this one, in the first 3-dot thing here, we're going to put while the file it hasn't ended. So it's going to be the not FEOF of the input files, which is input. And this is the thing where we use the get char from the file and compare it to a new line to count the lines. This is very similar to the example I already made during the class today. And in the second one, this is just going to be an fscanf that reads the thing in a specific format. And if you struggle, just rewatch the stream. I actually showed it on the stream when I looked at the homework. So you can just kind of copy it from there. This should be kind of easy. And any trouble, just let me know. But I'll let you guys start getting to work on this or any other stuff you have pending, and I'll catch you next week.